This video will show some examples of how to find the domain of rational functions. For any rational function, we find the domain by finding the values of x that make the denominator equal to 0. In these examples, you notice that we don't worry about the numerator. The domain is completely determined by the denominator. You'll also notice that all these problems boil down to is solving a polynomial equation. This first example is the quotient of two linear functions. To find the value of x that we can't put into this function, we need to find the value of x that makes this denominator 0. So we do that by setting up the equation 3x minus 4 equals 0. It's a linear equation and can be easily solved for x. So we see x is 4/3. So all real numbers can be put into this function except x equals 4/3. Here's a graph of this function. Notice the vertical asymptote corresponds to x equals 4/3. Here's an example of a denominator that's a quadratic function. And this is a nice quadratic function because it's just the difference of two squares. So we're going to, like we did before, take the denominator, set it equal to 0, and solve for x. This is an easy one. I can move the 4 to the right, take the square root of both sides, and I get x equals 2 and x equals minus 2. So I can put any real number in this function except x equals 2 and x equals minus 2. And here it is in interval notation. Here's the graph. Notice it has two vertical asymptotes, one at x equals minus 2 and one at x equals 2. This example has a binomial cubic in the denominator. So again, I ignore the numerator and I just set the denominator equal to 0 and solve for x. So even though this is a higher order polynomial, since it's just two terms like this, I can move this constant term over to the right and take the cube root in this case of both sides. So the domain of this function is all real numbers except the cube root of 3. Here's the graph of this function. Again, the vertical asymptote is at x equals the cube root of 3. This example has a quadratic function as the denominator of the rational function. Again, I set this quadratic equal to 0 and solve it. So this quadratic can be solved easily by factoring. So I factor it, I set each factor equal to 0, and solve. So the domain of this rational function is all real numbers except minus 4 and minus 3. Here's the graph. Notice it has two vertical asymptotes at x equals minus 4 and x equals minus 3. This example has a quadratic function as a denominator, but this time it's not easily factored. So I'm going to use the quadratic formula because that works in any quadratic equation once it's set equal to 0. And notice that when I use the quadratic equation, I'm going to get a negative value underneath this radical sign. So that means that I don't have any real zeros for this equation. So that means that there aren't zeros of our denominator. So all values of x can go into our rational function. So the domain is all real numbers. Here's the graph. Notice there aren't any vertical asymptotes.